back, let's continue our discussion of significant figures by reviewing how we measure, count, and do mathematical manipulations with significant figures. Now, I learned this when I first started teaching chemistry at the high school level, and I think it's a great trick that we have here. What the trick does require, though, is that you know that the Pacific Ocean is on the west or left-hand side of a map, and that the Atlantic Ocean is on the east or the right-hand side of the map. So that's really key to being able to do this. Now, to count significant figures, what we want to do is look at the number, and if I have non-zero numbers, it's no issue. They're all significant. The difficulty comes about with our zeros. Zeros play two roles. Zeros can be part of the measurement, like you estimated that the last digit was right on the line, so it's part of the measurement, but zeros can also be used simply to indicate magnitude. Now, if it is part of the measurement, it's significant. If it is not part of the measurement, if it's a magnitude, it's not significant. So let's take a look at this number. Do you notice that there is no decimal point explicitly given in this problem? So absent decimal, when it's an absent decimal, there's no explicit decimal point. When that happens, we're going to start from the Atlantic or the right-hand side of our number and move from right to left. And as we do this, we're going to not count anything until we hit our first non-zero. Once we hit our first non-zero, then we start counting, and then everything counts until you fall off the map, so to speak. So that's 2, 3, 4 significant figures. So we'd say that this has 4 sig figs. I'll be using that symbol SF quite a bit this semester. So that would have 4 significant figures. Now look at the effect of simply adding a decimal point here. If you add a decimal point, that's telling me that I have more significant figures, that these zeros are doing more than simply holding a position of magnitude. So when I do that, since I have a present decimal system, I'm going to start from the left-hand side. You start counting at your first non-zero. 1, 2, 3, 4, 5, 6. So that number as written would have 6 significant figures. Now, what is nice about scientific notation is it takes this guesswork or figuring out of the equation. So that first number we looked at would be 4.509 times 10 to the 5th power. It's clear that I have 4 significant figures because I don't need any zeros to tell me magnitude, because my exponent is what gives me my magnitude for my number. So every number in front, if we use scientific notation, is significant. Now, if I had to write that second, I would write 4.50900 times 10 to the 5th. Again, indicating what we'd already figured out is that we have 6 significant figures in that number. Now let me review just a couple more before I forge ahead into the mathematical rules again and reviewing some of those. Let's take a look at this number. If I had 0.450900, you first ask yourself, do you have an explicit decimal point present? And the answer is yes. So we want to start from the present decimal or Pacific side. You start with your first non-zero number. The 0 in front is often used just to clarify the position of that decimal point, and I think it's a wise thing to do. So that's 1, 2, 3, 4, 5, 6 significant figures in that case. Now, another scenario would be 0.004509. Again, we have that explicit decimal point. You start from the Pacific or present decimal side. Don't start counting till your first non-zero. and you have 1, 2, 3, 4 significant figures. If I were to write that in scientific notation, I'd put 4.509 times 10 to the minus third. And that clearly lays out my 4 significant figures. Now, when we're doing our mathematics in terms of the operations of multiplication and division, what you want is if it's all multiplication and division, you want your final answer to have no more significance than your least significant measurement. So you look at your givens, you count your sig figs, and you select the one with the fewest number of sig figs. Now, you did that quite a bit in pre-AP, so I'm not going to cover that in any more detail than just reminding you of that rule. Now, for addition and subtraction, we don't go by number of sig figs, rather we go by the decimal place that we have in our numbers. So if we have 67.985, remember that 5 is uncertain, and then I'm going to put in 469.2. That 2 is uncertain, which means I'm totally clueless about what's in those spots there. And then I could add to that 3.73. There's my uncertainty, and again, I'm clueless in terms of what would go in that position. So if I were to add all those numbers up, I would get, if I did an addition, it would be the same thing for a subtraction, 540.915. But if we really look at this, what we find is that I'm absolutely clueless about that number. We're not even talking uncertainty. I'm clueless. I'm really clueless about that number because of our second value there. So truly where we need to go is to the 10th place. So you look at all the values, you find out which goes to the furthest to the left, and that would be the place that we would round this number to. And so in our case, I would round this to 540.9. Round it to the 10th place. So you count not total number, but you count digits to the furthest over towards the left. Now, we're not going to see this last one for a while. I'm going to go ahead and give it to you for completion. I've never seen AP really test on this. This doesn't mean they won't. In this case, if we're going to be taking the log or the natural log of a problem, for example, you do know this formula. pH, I hope you remember this formula. pH is equal to minus the log of your H plus concentration. Now, when we do this, if I had a concentration, so if my log was log of 4.678 times 10 to the minus fourth, we're going to learn to estimate this later, we would have a pH of 3.3299. Now, in this case, what we have is we have these values here indicating the significance or limits of our measurement, and it's this number that relates to magnitude. That number is actually related to this 10 to the minus fourth. And we'll see that in a little bit more detail later on. Now, in the next lesson, we're going to do just a quick mini-mole lesson.